Welcome to a new topic where we learn the mechanics of economic growth and how it affects investment decisions. In this first lesson, we study factors that influence GDP growth. We first learn what the preconditions for growth are, followed by the production function, and how it translates to growth accounting relations. Let's get started. We've learnt in Level 1 that GDP is a measure of the economic output of a country. GDP per capita is this figure, divided by the population of the country. It reflects the average standard of living in each country. Growth in real GDP measures how rapidly the total economy is expanding. Growth in real GDP per capita implies a rising standard of living. This is why sometimes GDP per capita growth is a preferred measure of a country's economic progress. Historically, there have been large variations in both GDP growth rates and per capita GDP across countries. To understand why, we need to first consider the sources of economic growth. Capital and labour resources are the primary factors of production. Together with the use of technology, these are the primary sources of GDP growth. Before diving into these three primary sources of growth, let's first discuss some of the preconditions that help to foster an environment of growth. The first precondition is an adequate level of savings and investment. For countries to grow, private and public sector investment must provide a sufficient level of capital. However, it can be difficult for some developing nations to accumulate sufficient domestic savings to invest in physical capital due to low disposable income. In such a case, the country has to attract foreign investment to help kickstart GDP growth so that its domestic savings can grow. Secondly, there should be functional financial markets and intermediaries to allocate resources efficiently. Evidence suggests that countries with better financial markets and intermediaries grow at a faster rate. Efficient allocation of resources is achieved through screening and monitoring of entities who seek and obtain funding, creating financial instruments that facilitate risk transfer, diversification, and enhance liquidity, and pooling small amounts of savings from investors to finance projects on larger scales. Third, to attract foreign investments, a country should be open to free trade and unrestricted capital flows. Foreign capital can be invested directly in assets such as property, physical plant, and equipment, which we call foreign direct investments, or invested indirectly in financial assets such as stocks and bonds. Besides, free trade promotes growth by providing competition for domestic firms, thus increasing overall efficiency and reducing costs. Another important prerequisite to encourage foreign investments is political stability, rule of law, and property rights. Countries that have a developed system of property rights for both physical and intellectual property are better able to attract foreign capital. Economic uncertainty caused by wars, corruption, and social unrest poses unacceptable risk to many investors, reducing potential economic growth. Fifth, a good education and healthcare system. Countries that invest more in education and healthcare systems tend to have higher growth rates. Developed countries benefit the most from post-secondary education spending, which has been shown to foster innovation. Less developed countries benefit the most from spending on primary and secondary education, which enables the workforce to apply the technology developed elsewhere. And lastly, the tax and regulatory systems need to be favourable for economies to grow. All else equal, the lower the tax and regulatory burdens, the higher the rate of economic growth. Besides, lower levels of regulation help foster entrepreneurial activity. These are the 6 preconditions that help foster economic growth. These activities or models help to grow the capital, labour, and technology of a country, which are the primary sources of economic growth. One common and simple model used to explain the aggregate economic output of an economy as a function of these 3 factors is the Cobb-Douglas production function. L is the size of the labour force, K is the amount of capital available, and T is the total factor productivity, which is a proxy for technology. Generally, total factor productivity cannot be observed directly and must be inferred based on the other factors. We'll discuss more on this later. Alpha is the share of output allocated to capital, and 1 minus alpha is the share of output allocated to labour. There are 2 important properties that define the Cobb-Douglas function. Firstly, it exhibits constant returns to scale, meaning that if both the capital and labour inputs are increased by the same percentage, the output increases by the same percentage. Under this assumption, we can divide both sides of the relationship by L to get the output per worker, which is a measure of labour productivity. This equation tells us that the amount of goods a worker can produce depends on the level of technology, the amount of capital available for each worker, and the share of capital in GDP, denoted by alpha. And that brings us to the second important property that the Cobb-Douglas production function exhibits, diminishing marginal productivity. Assuming that labour and alpha remain constant, increases in labour productivity can be gained by improving technology and/or by increasing the capital per worker. We call this capital deepening. For a given level of technology, as the capital per worker increases, the output per worker should also increase. However, as alpha is a ratio between 0 and 1, this increase is not proportional. For example, a worker can produce one box with one machine, but if you give the same worker one more machine, she may produce just 70% more. And if you give her a third machine, she may produce just another 30% more. This is what is meant by diminishing marginal productivity. The lower the value of alpha, the flatter is this curve, and vice versa. Just looking at the curve, we can infer that the effect of capital deepening diminishes further up the curve. For example, developed markets tend to already be at a high capital to labour ratio, so increasing the amount of capital investments may do little to increase labour productivity. Contrast that to developing markets which operate at a much lower capital to labour ratio. For the same amount of capital deepening, the increase in labour productivity is much higher. This is one of the reasons why GDP growth rates in developing nations are significantly higher than that of developed nations. Regardless, all markets will eventually get to a point where profit-maximising producers will stop adding capital. This point is very significant in the neoclassical model of growth, where per capita growth in the economy will come to a halt. We will elaborate more on this in a later lesson, but for now just know that this is the equilibrium point where the marginal product of capital and the marginal cost of capital are equal. Producers will not want to borrow at a higher cost to produce less than that cost. Nevertheless, not all is lost for developed nations that have reached this point. Technological progress shifts the productivity curve upward and will lead to increased productivity at all levels of capital per worker. So if the investment in capital has resulted in technological progress, the labour productivity increases at a much higher rate, so the developed market can enjoy higher rates of GDP growth. In essence, the labour productivity growth is the sum of the growth due to capital deepening and the growth due to technological change. More often than not, an economist is more interested to study the growth rate in potential GDP of an economy based on these factors. A famous economist named Solow decomposed the Cobb-Douglas production function to be expressed in terms of percentage change. We call this the Solow's approach to the growth accounting relation, where the growth rate in potential GDP is equal to the long-term growth rate of technology plus the long-term growth rate of capital multiplied by the share of income paid to capital plus the long-term growth rate of labour multiplied by the share of income paid to labour. Very often you may see the alphabet A used to denote technology or total factor productivity, so we'll use it here. In practice, levels of capital and labour, their growth rates and their share of national income are quantifiable, so these can be forecasted. Technology or total factor productivity, however, is not that easily observable. Therefore, it's often estimated based on past data. For example, if the average GDP growth rate for Megaland in the past 10 years is 4.3%, the growth rate of capital was 3.6%, growth rate of labour was 0.6%, and 30% of national income goes to the labour force, can you estimate the long-term growth of technology for Megaland? Pause for a while to work it out. You should get 1.6%. Once we have an estimate to the TFP of an economy, we can use it to make forecasts of the potential GDP growth in the future using the same equation. Let's look at an example. Megaland has a developed market economy where the capital costs accounts for 70% of total factor cost. The growth rate of capital is expected to maintain at 3.6%, and the total factor productivity is estimated to be 1.6%. However, due to a rapidly aging population and strict immigration policies, the labour force is expected to contract by 0.2% each year. Based on these figures, forecast the rate of potential GDP growth for Megaland. Pause the video now and work out your answer. And we're back. Let's fit the items one by one into the growth accounting equation. Capital costs accounts for 70% of total factor cost, so alpha is 0.7. 1 minus alpha is therefore 0.3. Growth rate of capital is 3.6%, and the TFP is 1.6%. Growth of labour force is minus 0.2%. Punch all of these into your calculator, and the rate of potential GDP growth is therefore 4.06%. An alternative method of measuring potential GDP is to examine the size of the labour force and labour productivity. When stated in terms of growth, we find that the growth in potential GDP of an economy boils down to the growth in labour force plus the growth in labour productivity. As such, an economy's long-term potential GDP growth rate can be estimated by estimating the long-term growth rate of the labour force and the long-term growth rate of labour productivity. We call this the labour productivity growth accounting equation. For example, if Japan's labour force is projected to shrink by 1% in the long term, while its labour productivity is expected to grow by 2.5%, then we would estimate the long-term growth in potential GDP as 1.5% per year. Now, if we compare Solow's approach and the labour productivity approach, you'll immediately see the advantage of the labour productivity approach. You don't have to estimate the growth of capital input, the share of national income for capital and labour, and most importantly, the difficulty associated with measuring total factor productivity. However, the difficult part is to estimate the long-term growth rate in labour productivity. The effects of both capital deepening and technological progress are reflected in labour productivity. In contrast, the effects of capital deepening and technological progress are distinct under Solow's approach. Regardless of the approach, the study of the long-term sustainable rate of economic growth is important because long-term equity returns are highly dependent on economic growth over time. In the next lesson, we shall study the relationship between the sustainable growth rate, stock market returns, and the implications for investors. See you again.